Good day, students. In this clip, we're going to be going over the first part of our review for the midterm. So this is going to be focusing on trigonometric identities, okay? All right, so let's go ahead and take a look at question number one. It says, find the exact value of cosine negative 5 pi over 12. All right, so for this one, we're going to be using the sum and difference identity. But to make our lives easier, let's go ahead and change this angle into degree form, okay? So to change negative 5 pi over 12 to degree form, what we're going to do is multiply it by the conversion factor, which is 180 over pi, all right? So pi goes here once, pi goes here once, 12 goes here once, 12 goes here 15 times, and then negative 5 times 15 is negative 75 degrees. All right, so that's what we're going to be looking for. So we want to look for cosine, the exact value of cosine negative 75 degrees. All right, so we're going to consult our unit circle and find two common angles that add or subtract to give 75. So for this problem, I'm going to use 45 and 120. Okay, so for this one, so looking at our unit circle, we can see that we have 45 degrees and 120 degrees here. And those two, the difference is basically negative 75, okay? So let's go ahead and use those two angles. So this one, we're going to express it as cosine. So let's go ahead and write it down. So we have cosine 45 minus 120 degrees, okay? So you can see that we have a difference of angles here, so we're going to be using the difference identities for cosine, all right? So the first angle is alpha minus the second angle, which is beta, all right? So let's go ahead and find out the coordinates of this angles. Well, let's probably can do the angle first. So we're looking at cosine alpha minus beta. So using the difference identities for cosine, this is going to be cosine alpha, cosine beta, plus sine alpha, sine beta, okay? So this is what we're going to be looking for. All right, so alpha is 45 degrees, and when we consult our unit circle, let's go ahead and do that, we'll see that the coordinates of 45 degrees are root 2 over 2 and root 2 over 2. And the coordinates of 120 is negative 1/2 and root 3 over 2. Okay, so let's go ahead and write those down. So for 45, we have the coordinates are root 2 over 2 and root 2 over 2. And then for beta, beta is 120 degrees. And then the coordinates are negative 1/2 and root 3 over 2. Okay? Now the x coordinates are cosine and the y coordinates are sine. Okay? So we can make ourselves a little chart right here to help us delineate the respective values for each coordinate. Okay? Alright, now we have all the information we need to find out what the cosine and sine of the two trig angles are. Alright, so let's do this. We're going to write let's write down the formula again. Cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. Okay? Alright, we're looking for cosine 45 minus 120. So I'm going to use this formula as a guide, okay? So cosine alpha is going to be cosine 45. Cosine beta is cosine 120. We already established that earlier here. This is alpha and this is beta. Plus sine alpha is 45. Sine beta is sine 120. Okay? Alright, so what is cosine 45? Cosine 45 is the x-coordinate of 45, the coordinates of 45 degrees, which is root 2 over 2, times cosine 120 is the x-coordinate of 120, which is negative 1/2, plus sine 45 is root 2 over 2, times sine 120 is the y-coordinate for 120, which is root 3 over 2. Okay? So if we multiply these out, we're going to get negative root 2 over 4 plus root 6 over 4. All right, we can combine it as one fraction. We have negative root 2 plus root 6 over 4. And if we factor out the minus, our final answer will be negative root 2. Since we took out a minus from here, it's going to change to minus root 6. This whole thing divided by 4. All right, so there you have it. All right, so our answer here for this problem is A. Answer is A, but if you notice there was a mistake in the question. This in the options, this is supposed to be a 2, and this is supposed to be a 6. Okay, so the correct answer is option A. All right, now let's move on to question number 2. Question 2, we have to find sine A plus B when A is 5 over 8 in the second quadrant and B is 2 over 4 in the fourth quadrant. All right, so let's first of all write down, apply the sum identities for sine, and then find the missing pieces. So for this problem, sine A plus B equals, using the sum identities for sine A cosine B plus cosine A sine B. All right, if you look at this problem, you notice that we have sine A, check, and we have cosine B, check. We need to find cosine A and sine B, all right? So we're going to use the Pythagorean identity on these two to find the other related trig function. All right, so the first thing we're going to find, let's go ahead and find cosine A. All right, okay, so to find cosine A, we're going to use the identity cosine A equals plus or minus the square root of 1 minus sine square A. All right, so applying that, we're going to have cosine A equals plus or minus the square root of 1 minus sine A is 5 over 8, as you can see here, 5 over 8 squared. Okay, now we're going to do some arithmetic to finally find out what cosine A is. So we're going to have the square root plus or minus, we don't know the sign yet, 1 minus 25 over 64. All right, express 1 as a fraction, 1 over 1. To find the LCD, we'll multiply by 64 top and bottom. And then that's going to yield plus or minus a square root of 64 over 64 minus 25 over 64. That gives us plus or minus the square root of 39 over 64. And then when we read the top and bottom, we have plus or minus root 39 over 8. Okay? Now let's see if root 39 can be reduced any further. So root 39, take out 3 and 13. These are both prime, so it cannot be reduced. All right, so guess what? Cosine A is plus or minus root 39 over 8. So the question now is it positive or negative? Now the restrictions on A will tell us what it is. Remember, we're told here that A is between pi over 2 and pi. Okay, so let's see what quadrant that lies in. So we draw a coordinate system like this. So we have 0, this is 0, pi over 2, or 90 degrees, and pi. Since we're between pi over 2 and pi, we're in quadrant number 2. And we know that all students take calculus. In quadrant 2, S means sine and cosecant are positive. So this is neither sine nor cosecant, so guess what? Cosine A is negative. So we have cosine A is equal to negative root 39 over 8. Okay? Note, cosine is negative in quadrant 2. All right, we have one piece. Now we need another piece that we're looking for is sine B. Okay, so let's go ahead and find that. So we're going to want to find sine B. We're going to use the Pythagorean identity. the one we used before, but with the sine and cosine switch. So now sine B is going to be plus or minus the square root of 1 minus cosine square B. All right. Okay, so that tells us that sine B is going to be plus or minus. We know what cosine B was given to us as 2 over 5, so 1 minus 2 over 5 square. All right, let's do some arithmetic to figure out what sine B is. So we're going to have plus or minus the square root of 1 over 1 minus 4 over 25. To find the LCD, we'll multiply this top and bottom by 25. 25 and 25. So that we're going to have plus or minus the square root of 25 over 25 minus 4 over 25. Okay? Subtract it, we'll have plus or minus the square root of 21 over 25. And then we can break down the square root into root 21. And if you root the denominator, it's going to be 5. Okay? We'll break down 21. 21 is 7 times 3, so we cannot reduce 21 any further. All right? So this tells me that sine B is plus or minus root 21 over 5. So is it positive or negative? Well, let's go ahead and make a coordinate system to determine what the sign is. So make a coordinate system. This is 0, pi over 2, pi. And let's see. What are the constraints on B? B is between negative pi over 2 and 0. Okay? So we're actually supposed to label in the reverse direction. Note that when you're labeling, positive angles go in this direction, and negative angular measures go in this direction. Okay? So since we're between 0 and negative pi, we're going down, negative pi over 2, so this would be negative pi over 2 downstairs here, and this will also be negative pi. All right, so we're going to be in quadrant 4 for B. So we know that all students take calculus. This C basically means that only cosine and secant are positive in quadrant 4. Is sine, cosine, or secant? No. So guess what? Sine is negative in quadrant 4. All right. So we can conclude that sine B is what? Sine B is negative root 21 over 5. Okay, so let's rewrite what we had earlier for sine A plus B. So we said earlier that sine A plus B, using the sum identities for sine, is sine A cosine B plus cosine A sine B. All right. So now we have everything that we need. Sine A is 5 over 8. So we have 5 over 8 times cosine B is, let's put this in parentheses, sine A cosine B is 2 over 5 plus cosine A, we found it earlier, is negative root 39 over 8. And sine B is negative root 21 over 5. All right, so let's multiply. We're going to have 10 over 40. And then multiplying this out is going to be minus times minus is positive, so we have plus root 819 over 40. Okay, so let's see if we can reduce root 819. Let's do that on the side. So the square root of 819, we'll take out 3. 3 goes into 819 273 times. And take out another 3. 3 goes into 273 91 times. And then 7 goes into 91. 7 goes into 91 13 times. Okay? So you see that these two repeat, so they break out as a 3. The square root of 3 times 3 is just 3. So root 819 is basically 3 root 91, because that's what's left here, root 91. 91 is 7 times 13. Okay? So we can write our final answer as 10 plus 3 root 91, the whole thing divided by 40. Okay? And there goes your final answer. So our answer for question number 2 is B. Okay. All right. Moving along to to question number 3. Says from the list below, find the expression equivalent to sine 42 degrees. When we take a look at these angles, they look the first A, C, and D look like the double angle identity. This is the Pythagorean identity. But if you notice, the angles are being halved here, so it looks like we're going to be using the double angle identity. So what's the double angle identity for sine? Sine 2 theta, the double angle identity for sine equals 2 sine theta cosine theta. Okay? If you look at these options, you can obviously see that the answer is C without doing any work. But let's go ahead and do the steps, okay? So the argument is 2 theta for sine, so we're going to equate these two arguments together to each other. So 2 theta equals 42. So to get theta by itself, divide both sides by 2, divide by 2, divide by 2, and then we have theta equals 42 over 2 is 21 degrees. Okay? Now we're going to substitute theta into the right side of the equation. So we have sine 42 is equal to 2 sine theta, which is 21, cosine theta, which is 21. And there goes your final result. Okay? All right. So our correct answer for number 3 is option letter C. Okay, let's move on to the next question. Question 4. It says find the exact value of sine 105. We're going to be using the sum and difference identities here depending on how we want to split it. So sine 105, let's see, are there two common angles that add or subtract to give you 105? So we're going to be using the difference identity for this problem. So let's see, what's two angles on the unit circle? Common angles add or subtract to give you 105. We can do 150 minus 45. 150 minus 45 is 105, all right? So let's go ahead and do that. So sine 105 is basically sine 150 minus 45, okay? So since we're using the difference of angles here, we're going to use the difference identity for sine to figure out this problem, right? So what is the difference identity for sine? Well, we have, let's set it up on top. Sine alpha minus beta is going to be sine alpha cosine beta minus cosine alpha sine beta. Okay? All right, so let's apply that to this problem. We can clearly see in this problem that alpha is 150 and beta is 45. Okay, so let's apply that here. So this is going to be sine 150 cosine 45 minus cosine 150 sine 45. All right? Okay, so we need to find the value of these. So now let's consult our unit circle again. 150 is negative root 3 over 2 and 1 half. And then 45 is root 2 over 2 and root 2 over 2. All right, so let's write down the value of these coordinates on our unit circle, on our next to each angle. So 150 is negative root 3 over 2, comma 1 half. And then 45 degrees is root 2 over 2, comma root 2 over 2. Okay? All right, so we know that, let's divvy down the center. The x-coordinate is cosine, and the y-coordinate is sine. Okay? All right, now we're going to use this mini chart we have created here to figure out what the value of this expression, this long expression we have here is. Okay, so let's go ahead and figure out what it is. So we have sine 105 equals sine 150 is 1 half, so we have 1 half. Cosine 150, cosine 45, sorry, is root 2 over 2. So root 2 over 2 minus cosine 150 is the x-coordinate here, which is negative root 3 over 2. And then sine 45 is root 2 over 2. Okay, so there we have it. Now let's go ahead and simplify. So we're going to have root 2 over 4 minus times minus is plus root 6 over 4. And as a combined fraction, we can write this as root 2 plus root 6, the whole thing divided by 4. Alright, so our correct answer for question number 4 is A. Alright, let's move along to the next question. Number 5, it says from the list below, find the expression equivalent to cosine 56 degrees. So, if you look at these three, B, C, D are the half-angle identities. These are in the form of the half-angle identities, but this is in the form of a double-angle identity. But this is a double-angle identity that's in sines form. Remember, for cosine, if you look at your formula sheet, cosine 2 theta is equal to 1 minus 2 sine squared theta, which is also equal to 2 cosine squared theta minus 1, which is also equal to cosine squared theta minus sine squared theta. Okay? So you can see that this is not of this form. This is of the sine form. And if this were sine, this would even be a wrong option. So we can eliminate option A because it's not in any of these forms. Okay? So the question is, what is the half-angle identity for cosine? So cosine alpha over 2, the half-angle angle identity for cosine is plus or minus the square root of 1 plus 1 plus cosine alpha divided by 2. Okay? Alright, so if you take a look at these three, you notice that this is actually the one for tan. The half-angle identities is for tan alpha over 2. This one is for cosine alpha over 2. And this one is neither. This is a totally wrong formula. This is not for sine. The one for sine is like cosine but with a negative. So just by inspection, we can see that this matches with option C. Okay? So let's go ahead and show that this is in fact the case. So what we're going to do is we're going to set the angle, the argument here for cosine, the angle to alpha over 2. Okay? Alpha over 2 equals 56. So we need alpha to substitute into the right side of our equation to get a result. So to achieve that, we're going to multiply both sides by 2. This divides out. So we have alpha equals 112. Alright, so let's plug that into our equation. So that tells me that cosine 56 using the half angle identity equals plus or minus the square root of 1 plus cosine alpha. Alpha has been determined to be 112. We'll put that in there, divided by 2. And there goes your answer, and we can see that the answer is in fact option C. So there goes our answer. Hey there students, welcome to part 2 of the midterm test review. We're going to be focusing on vectors in the following 5 problems we're going to do. So let's go ahead and take a look at question number 6. So number 6, in a warehouse, a box is being pushed up a 20-degree inclined plane with a force of 3 pounds, as shown in the figure. What is the horizontal component of the force? So remember your resolution of forces into its components, breaking down forces into its components. Let's write down some formulas. We have 2 components, the vertical and the horizontal. The vertical component is a component that's opposite the angle, and you remember in SOHCAHTOA, the one that relates the opposite and the hypotenuse is sine. So the vertical component, I'm going to call it f of y, is basically f sine theta. Okay? So let me draw a graph of the situation so that you can understand what I'm talking about. So let's say you have a force acting at an angle. This force, this is the horizontal component of the force, and this is the vertical component of the force. Okay, I'm gonna draw it here, but it's the same thing. So this is the angle theta right here. The hypotenuse is basically the force. Okay, the magnitude of the force to be exact. So this is the force right here, and this is the vertical component of the force, f sub y. So it's the one that relates the hypotenuse in this side and that side, opposite of hypotenuse. So F sine theta is the vertical component, okay? So the horizontal component, horizontal, is the one along the x-axis, f sub x, and that's the adjacent, okay? This is the opposite, this is the opposite right here, and this is the adjacent. This is f sub x. So the trig ratio that relates the adjacent and the hypotenuse is this cosine, right? From ka into katoa. So the one we're focusing on for the vertical component and the horizontal component, f sub x is the cap piece. Okay, so f sub x, the horizontal component is f cosine theta. Okay, so in this problem we are asked to find just the horizontal component. So all we're looking for is this piece right here. Okay, so horizontal component, let's write it again. Horizontal component. In this case, we can clearly see that this is f. So f is equal to 3 pounds, and theta of the angle of the force from the horizontal was 20 degrees. So the horizontal component f of x is equal to 3 cosine theta, which is 20 degrees. All right, so we just plug that into our calculator. So we're gonna have, let's see, we set my mode to to degrees. Make sure we're in the right mode. So f 3 cosine 20 yields 2.8191. To two decimal places is 2.82. Okay, so our answer is going to be F's the horizontal component of force is approximately 2.82 pounds. Okay, so our answer is option B. All right, let's move along to number 7. It says that u equals negative 5I minus j and v equals negative 5I plus j. Which of the following is equal to u plus 3v? So it's a linear combination of two vectors. So we have u equals negative 5I minus j, but we notice that vector v was scaled by a factor of 3. Okay, so v is negative 5I plus j. So what does that tell me? That tells me that 3v is going to be 3 times the vector v. Okay, so it's going to be 3 times negative 5I plus j. Okay, so what do I do here? I just simply distribute the 3 to the two components, the horizontal component and the vertical component. All right, draw my arrows again. Horizontal and vertical components get scaled by a factor of 3. All right, so 3v is basically going to be equal to negative 15I plus 3j. Okay, so we have to find the value of u plus 3v. Okay, these are vectors. So u is negative 5I minus j, and then 3v as we found here is negative 15I plus 3j. Okay, so we're just going to add the i's and the j components. We're going to add them vertically. So let's go ahead and do that. Negative 5 minus 15 is negative 20, negative 20I, and then negative j plus 3 is plus 2j. Okay, negative 20I plus 2j is what is equal to u plus 3v. So our answer is option C. All right, let's move on to question number 8. It says find the work performed when the given force F, vector F, applies to an object whose resultant motion is represented by the displacement vector d. Assuming the force is in pounds and the displacement is measured in feet, use the formula work equals the dot product of F times d. I mean, the dot product of F and d. Okay, so to look for the work done, we're going to be dotting vector F and vector d. So that's going to be, is expressed in the ij form. So we're going to have 45I minus 12j dotted with 80I. Let's try that again. dotted with j dotted with 80I plus 5j. Okay, so remember the formula for finding the dot product. Let's write it up here. You have AI plus bj. Let's call this, yeah, AI plus bj being dotted with ci plus dj. All you simply do here is you multiply the I components, a times c, and it's added to the to the j components, which is b times d. Okay, so multiply the I components like the x's, so like the x's, x1, x2, multiply the x's, and then the y's, y1, x2, y1, y2. Okay, so you multiply the x's and then the y's, and then you find the sum. All right, so that's basically how you find the all right, so let's apply that formula here. So we're going to have, it's going to become 45 times 80 plus negative 12 times 5. Okay? All right, so if we multiply it out, we're going to have 45 times 80 is 3600. And then negative 12 times 5 is negative 60. And the difference is 3,540 foot-pound of work that's been done. So our answer is option B. All right, let's move on to question number 9. Question 9 says find the dot product of z1 and z2 in standard form. So we have two vectors written in polar form, and we're asked to find the product of these two numbers. Okay. All right, so I kind of got it mixed up. This is the correct number 9. So yeah, let's do this one instead. All right, so question number 9 says what is the dot product of these two vectors? So let's set it up. So we have 5 times 4 times negative, 5 comma 4 comma negative 5. Right, again, 5 comma 4 comma negative 5. And we're dotting it with another 3D vector, which is negative 2 comma negative 5 times negative 1. So all you simply do here is you multiply the x's, the y's, and the z's, and then you find the sum of the products. Okay, so that's how you find out product. So we're gonna go 5 times negative 2, that's the product of the x's, plus 4 times negative 5, that's the product of the y's, plus negative 5 times negative 1, that's the product of the z's. Okay, all right, so let's work this out. We have negative 10 minus 20 minus 1 times minus 5 is positive 1. Okay, so this equals negative 30. Actually, this is plus 5. This is plus 5 right here. Okay, so minus 30 plus 5 equals negative 25. So the answer is option D. All right, let's move on to question number 10. It says a force of 60 pounds acts on an object at an angle of 25 degrees, and the second force of 60 pounds, same magnitude, acts on the same object at an angle of negative 70 degrees. What is the magnitude and direction of the resultant force? Okay, so let's draw a coordinate system to orient our vectors relative to the same point. So let's say that, let's place our object on the origin. Okay, so this is our object, it resides right here. Okay, so the first force of uh, magnitude 60 pounds acts at an angle of 25 degrees. So let's say that's the vector right there. And then what I'm going to do is let's indicate the angle of rotation. It's going to be 25 degrees. So that's 25 degrees. Remember, when you're measuring angles, this is 0. If you go in this direction, uh, counterclockwise is positive, okay? And then if you go clockwise, that's negative. So this is a 60-pound vector acting on this object right here at an angle of 25 degrees. The second one is the same 60-pound, there's another 60-pound vector acting at negative 70 degrees. So let's go ahead and do that. So I'm just going to try and make a sketch of another vector. should be of the same length, but let's try our best to make it look like that. And it's going to be, all right, so there goes the second vector. Let's say this is our angular rotation of negative 70 degrees. So this is going down 70 degrees, going down negative 70 degrees. Okay, so this is also 60 pounds, 60-pound vector. All right, so we have to find the resultant force. We're going to use the parallelogram method here to find uh, out what the resultant vector looks like. Okay, so let's go ahead. We're going to translate this vector down here to the tip of the other vector, and then we're going to complete our parallelogram. Okay, so what I'm going to do is I'm going to take this vector uh, and translate it here, make it a dotted line, like that. And then I'm going to complete my parallelogram with another vectors, translating this vector up here to the tip of this vector down here. And there goes your parallelogram, okay? All right, so our resultant vector is going to be the vector that starts from the origin and ends at the tips of the two translated vectors. So this vector right here is the resultant force. Okay, that's resultant force. That's what we're looking for. The magnitude and its direction from 0 degrees, okay? All right, so let's go ahead and see what we can figure out with this information that we have. Um, This is a parallelogram, so we know that opposite sides are parallel and congruent. So if this is 60, this side has to measure 60 also. And we know in a parallelogram that adjacent angles are supplementary, okay? So this entire angle here is 25 plus 70, which is 95 degrees. So this entire angle here, this whole angle is 95 degrees. So if this is 95 degrees, that means this angle is going to be the supplement of that angle, okay? So in order for us to be precise with our measurements, let's label everything so we know which is which. So let's call this A, and let's call this C, and let's call this B, and we can call this D, okay? All right, so angle C and angle A are supplements, okay? They're supplements of one another. That means they add up to 180. So angle C is basically 180 degrees minus 95. Okay, so if you do the calculations, you find out that angle C is 85 degrees. All right, so this is 95. This angle right here is 85. The opposite angles of parallelogram are congruent, so this is also 95. And this angle right here is 85. Okay, so what I'm going to do is I'm going to extract this triangle that I have right here, and then I'm going to solve it for this force right here. That's the magnitude, and then later I'll figure out what the angle is. All right, let's go ahead and do that. All right, so let's just move that. Just do extract that down here. Let's put it over here. Well, let's put it to the side so we can see what we're working with. Okay, so let's put it over there. Okay, so let's focus our attention on this triangle now. It's congruent to this triangle up here. This is A, C, B. Okay, this vector starting from A to B, that's what we're looking for. That's the resultant force. We know that this is 85 degrees, this is 60, and that is also 60. Now, what uh, formula we're going to use to figure out the length of little c? Let's see what we have. This is S, side, and this is an angle, side. Just a real quick review. We know that side, angle, and angle, side are the formulas you use for the law of sines, right? And we also know that side, and side, angle, side are the formulas you use for the law of cosines, right? So in this scenario, we have side, angle, side, so we're going to be using the law of cosines. All right, the law of cosines, the only one that has a big C in it is the one with the formula of the form c squared equals a squared plus b squared minus 2ab cosine c. Okay, so let's use that to figure out the magnitude of this resultant force. So we have c squared equals 60 squared plus 60 squared minus 2 times 60 times 60 cosine big C, which is 85. All right. So let's plug that into our calculator and see what we get. Let's see, where's my calculator? There you go. Okay, so we have 60 square plus 60 square minus 2 times 60 times 60 cosine 85. Okay, and the answer is 6,6572.78. So let's write out 6572.48. So that's the value of c squared. So c squared equals 6572.48, which was approximately equal to that. So to get c by itself, we just simply take the square root of both sides. So root that and root that. And our final answer, C is going to be, let's see what C is. Well, to get C, we're going to take the square root of the answer we just got. So the square root of the answer is 81.07. Okay, 81.07 when rounded to two decimal places. Actually, it's supposed to round it to a whole number here. So it's simply going to be approximately 81 pounds. Okay, so 81 pounds is the magnitude of the vector. So answer is either A or D, can be B or C. So to find out what the direction is, what we're looking for is this angle right here. The angle, let me extend this side so we can see. The angular measure from 0 degrees, to this side right here. So what we're looking for, we mark it in blue, is this angular measure right here. How many degrees is that? Okay. So there are many ways you can do that. Well, the easiest way is to just simply use averages to figure out what that angular measure is. Okay. So I'm going to use averages to figure this out. So uh, direction, I'm going to average the angles. So direction, I'm going to use theta average. Theta average is basically the sum of the two angles, theta 1 plus theta 2, over the number of angles, which is 3, and which is 2. Okay? So theta 1 is the 25-degree angle. The second one was negative 70. So where is the middle of these two? That's what we're looking for. When we add them up, negative 25 plus 70, we have negative 55 degrees. When you divide it by 2, you're going to get negative 22.5. So theta average is negative 22.5 degrees. So this is the direction. Okay. So our final answer is option A. So there you have it. Good day, students. Welcome to part 3 of the review for your midterm. In this section, we're going to be going over the law of sines, law of cosines, and also the area formula. Okay. Let's take a look at question number 11. It says, given triangle ABC, with little a equals 8, big C equals 25, and big B equals 32, find little c. All right, so in order for us to be able to fully understand this scenario and accurately label our triangle, it's beneficial to make a sketch of the situation. Okay, so let's go ahead and make a sketch, not to scale, of what we're looking at here. Okay, all right, so there goes my typical triangle ABC. Let's label them using the correct fashion. So this is uppercase A, so that makes that little a. This is uppercase B, that makes this little b. The side opposite it, uppercase C, that makes it the side opposite little c. Okay. All right, so little a is 8. Big C is 25. 25. You put the angles inside and the side measures outside. So big C is 25. Big B is 32. And we have to find little c. So that's what we're looking for. All right, so let's look at the situation that we have here. We have angle, side, angle. Okay, so what do we use to solve angle, side, angle scenarios? Remember that um, in order to use the law of sines, we need a pair. So it comes in two fashions, either SSA or AAS. So anytime we have SSA or AAS, we use love signs. And then if we have SAS or SSS, we use the law of cosines. Okay? All right, so in this scenario, this is neither SSA or it's not any of these. It doesn't match. This is ASA that we have here. So since we do not have a match, then we have to resort to another approach. So let's see, what can we do to make it match one of these forms or to have a pair? Notice that we have two angles, so we can use the triangle angle sum theorem to figure out the last angle right here. Okay, and then we can be able to solve it using the law of sines. So let's go ahead and do that. So we're going to have to find angle A using the triangle angle sum theorem. Angle A is going to be 180 degrees minus the sum of the other two interior angles, which is 32 plus 25. Okay? If we plug that into our calculator, we'll find out that angle A is equal to 123 degrees. All right? Clearly, it's not drawn to scale. So angle A is 123 degrees. So if you look at this scenario, we have a pair and a pair with a missing side. We have a SSA situation, so we can use both signs to find angle C. All right? So what are we looking for here? We want to find C, little c. All right, so to do that, we're going to use the law of sines, little c over sine big C. This is a pair missing a piece, and the next pair has to have no missing pieces. And that the pair that satisfies that requirement is the A's, or are the A's. Okay? All right, so we're going to have a little a over sine big A. All right, let's go ahead and substitute and solve for little c. So little c is unknown over sine. Big C is 25 equals little a is 8 over sine big A, which is 123. Okay? All right, now let's get little c by itself and multiply both sides by sine 25. So sine 25 on the left and sine 25 on the right. This divides out, and we're going to end up with little c equals. Now let's plug in that entire expression into our calculators, see what we get. So let's plug in 8, where it is, 8 sine 25 equals that divided by sine 123 equals that. Enter. Final answer is 4.03. So answer is C, little c, is approximately 4.03. All right, so the answer to number 11 is option B. All right, so there you have it. Okay, let's take a look at question 12. So for question 12, we have to find the area of triangle ABC. Figure is not drawn to scale. So the area formula, K, I'm going to write it K equals 1/2 side times side sine of the angle. Okay, so there are three variations for this. Remember, you must have two sides and an included angle in order to do it. Okay, so if you have your triangle labeled correctly, the variations of this side and sine of the included angle is going to be K equals 1/2 AB sine C, or 1/2 BC sine A, or 1/2 AC sine B. So it depends on what you're given. But if you label your sides SAS, you can just plug it directly into this generic formula right here. Okay? All right, so notice what I'm going to do here. You're going to ask yourself, do you have an SAS situation? If so, you just take the two sides, multiply them together, 1/2, and then sine of the included angle. So here we have side, angle, side. All right? So following the order, side, angle, side, we can see that this can be directly applied to this formula, or this formula applies directly to this situation, okay? Um, so we're going to go area equals 1/2 the side, which is 4, times the other side, which is 5, sine of the included angle, which is 61. Okay, notice I didn't use any of these formulas. I just used this generic formula right here. But if I wanted to restrictive to focus mainly on the application of these formulas, let's label it. Let me show you the formula I'm using. So if that's big B, this is little b. If that's big C, this is little c. And then obviously that's big A. So the version of this formula I'm using is 1 half BC sine A. Okay? Notice I didn't have to do this. Just knowing SAS is sufficient to use the formula. Okay? All right, so let's go ahead and plug that into our calculators and see what we get. Let's see. I'm going to do 1 divided by 2 times 4 times 5 sine 61. Okay, and the answer is 8.75 to 2 decimal places. So the area is approximately 8.75 square centimeters. All right, so the answer is letter A. All right. All right, let's move on to the next question, question 13. Question 13 says, given triangle ABC with little b equals 10, little c equals 5, and angle A equals 34, find little a. Okay, so what formula are we going to use here? I have absolutely no idea, so let's go ahead and draw a sketch of the situation, and then after labeling it, we can be able to determine the appropriate formula for the situation. Okay, all right, so let's make a sketch. Not drawn to scale. This is ABC, so that makes this little a, little b, little c. Okay, now little b is 10, so this is 10. Little c is 5, and measure of angle A is 34. All right, so what situation do we have here? We have side, angle, side. All right, SAS, law of cosines is what we're going to use here. All right, so the law of cosine is that we're going to select is the one that has big A. There's only one that has big A, and that is A squared equals B squared plus C squared minus 2BC cosine A. All right, so let's substitute and isolate a little a. So we have a squared equals 10 squared plus 5 squared minus 2 times 10 times 5 cosine 34. All right, let's plug that into our calculator. I'll have our calculators do the heavy lifting here. So let's see, what do we have? We have 10 squared plus 5 squared minus 2 times 10 times 5 cosine 34. Answer is 42.0962. So a squared is approximately 42.0962. So we're not done yet. We have to take the square root of both sides to get the value of a. So take a square root, take the square root. And if I plug that into our calculators, we're going to get, so I'm just gonna take the square root of the previous answer I got, and my answer will be 6.488. To 2 decimal places, it will be 6.49. All right, so measure of side length A is approximately 6.49. 6.49. Okay. All right, so the answer to question number 13 is B. All right, now let's move on to the next one, question 14. Oh, that was 13. Sorry about that. All right, question 14. It says find the area of the triangle. So let's take a look at the situation that we have here. We want to find the area. If one uses the area formula, we must have SAS, two sides and included angle, and we can use the formula K equals 1 half the side times the side sine of the included angle A. Okay, SAS. What do we have here? Let's see what we have. We have S, S, A. SSA. This is no good. We cannot use this formula in this situation. In order for us to be able to apply this formula to this situation, we need to have at least an angle between two sides. So if I can find this angle right here, then I will have SAS using these two sides. Okay? So if we can find B, then we can use the angle, the area formula. Okay. All right. So let's write down the remark real quick so that we know what our focus is. So let me erase my labels so that we don't get confused. All right. I have two S's. I need an A. So let's write down the real quick remark. Um, in order in order to in order to use SAS formula for sines. This is the area formula for sines. Um, for the given two sides, for the given two sides, we need to find B. Okay, so in order to find B, we need to find C first. So uh, we must find C first. Okay, so we'll find C first, and then use that to find B using the triangle angle sine theorem. Okay, so we must find C first, then find B. All right, let's go ahead and find, why did I choose to find C first? Because if you're looking at, if we're thinking of using law of sines, we have a pair here. This is an SSA situation. And if you have SSA, remember that law of sines. We have a pair here, the A's, and an incomplete pair, which is the C's. So that's the screaming law of sines. So what we're going to do first is we're going to find little c. Okay, and law of sines is a choice here. So to find little c, we're going to go C over sine big C. And then the next pair has to have no missing pieces, okay? And A satisfies that requirement, so A over sine big A. All right, so now we're going to substitute and solve little c over sine big C. Actually, let's see, what are we looking for? We're looking for a big C. So let me restructure this. This formula is correct, but I kind of messed up my cases. So I'm going to go we want to find big C, we know little c. Okay, so to find big C, I'm going to switch it around a little bit. So sine big C over little c has a missing piece, which is big C over sine big A over little a. I like to place the variables I'm looking for on top. All right, so let's substitute. We have sine big C. Little c is, let's see. Let's label our triangle so we don't get confused. If this is big A, this is little a, and then this is little c. Okay, and then this is little b right there. All right, little c is 9 equals sine A, 65, sine 65 over little a is 20. All right, now to get sine c by itself, we'll multiply both sides by 9. So multiply by 9, and multiply by 9. Let's divide out. We have sine c equals, let's see what we get when we compute 9 sine 65 over 20. So let's do that. So parenthesis 9 sine 65, close that, divided by 20. Final answer is 0.4078. So sine C is approximately 0.4078. 0.4078. And then to get C by itself, we simply take the inverse sine of both sides. So big C is approximately the inverse sine of 0.4078. Plug that into our calculators. Let's see what we get. So we're going to do the inverse sine of, let me just use the previous answer, second function negative. So plugs in my previous answer, 24.0691. Okay, so big C is approximately 24.0691 degrees. Okay, now let's see if that's big C, 24.0691. Let's put that in here. 24.069. Now what is big B? We can simply use the triangle angle sum theorem to find it. Okay, so let's do that. To find big B, we're going to use big B equals 180 minus the sum of the two other angles, which are 65 and 24. So minus 65 plus 24.0691. So big B is going to be approximately, this is going to be an approximation since big C is an approximation also. So I'm going to go 180 minus parenthesis 65 plus, I'm going to call up my previous answer, second function, negative, enter. And angle C is 90.93. 90.9308. Okay, so let's use that, 90.9308. So let's write that down. Angle B is 90.9038 degrees. Now, what does that mean? Is the question. Well, let me just fix something real quick. It's 9308, not 9038. 9308. Okay, so are we done? Absolutely not. We're looking for angle B because that can help us find the area. So 90.9308. So now we can now use the SAS formula using little c, little a, and big B to find the area. Okay. So we're going to use the formula, find area now. To find the area, we're going to use the formula K equals 1 half AC sine B in this situation because we have SAS. So that's going to be 1 half. A is 20. C is 9. Sine the angle we got, which is 90.9308. Let's plug that into our calculators and see what we get. So we have, let's see, 1 half, 1 divided by 2 times 20 times 9 times the sine of, did the wrong function, sine of my previous answer, negative, enter. We have 89.988. Let's see our options right here. We're gonna round it up. So if you round up 89, it automatically becomes 90, 90, uh, 90 square inches. Okay, so the uh, area is approximately 90 square inches. All right, so the answer is option, for this problem is option letter B. Okay, let's go ahead and consider the next problem, question 15. Question 15, it says 3 ships are at sea, Admiral, Barstow, and Cauldron. Okay. The crew of Admiral reports that an angle 33 degrees is found between the line of sight and Barstow and the line of sight and Cauldron. So it looks like we have 3 points here. Let's go ahead and draw 3 points. Okay, not drawn to scale, obviously. I'm going to let A represent Admiral, B represent Barstow, and C represent Cauldron. Okay? All right, let's formulate a triangle, and then we're going to populate the measures using the information in this paragraph. Okay? So we have a triangle situation. So we're now starting from Admiral. Angle of 33 is between Barstow and Cauldron. So this is 33 degrees right here. Between Barstow and Cauldron, this angle right here. Okay? All right, and then says found between that, and then the radio Barstow, and by comparing all landmarks, find that the distance between Admiral and Barstow is 617 meters. So between Admiral and Barstow is 617. And it says the Barstow reports that an angle of 53 is found between the line of sight to Admiral and the line of sight to Cauldron. So between Admiral and Cauldron, the angle of separation here is 53 degrees. All right. So it says to the nearest meter, what is the distance between Barstow and Cauldron? So what is this distance right here, which is little a? Okay, so that's what we need to find. So if you look at what we have here, we have an ASA situation. So whenever I have ASA, we can convert it into an SSA situation. Actually, an AAS situation, because we can always find a third angle. So just like this, we have no pairs, you see? So we can't use law of sines, and this is not SAS nor SSS. so we can't use law of cosines either. But you notice we can find angle C. Okay, so let's do that first. Find big C so we can apply one of the laws that we know. So to find big C, we're going to use big C equals 180 minus 53 plus 33. Okay, if you do that in your calculator, you get 94 degrees. So this is 94 degrees. All right, so if you look at the situation that we have here, we have a pair that we know and a pair with a missing side. So that tells us that we can basically use A, AS. You see that? AAS? Uh, law of sines will work here. All right, so let's go ahead and solve this problem. To do that, we're going to indicate what we're looking for, which is little a. So we want to find little a. Little a is the distance between Barstow and Coldrew. Okay, so to find little a, we're going to go a over sine a equals the pair that we know, whether it's c, little c over sine big C. Okay, all right, now let's put in the measures that we know. A, we do not know, over sine big A. Sine big A is 33 equals little c is 617 over sine big C. Big C is the measure we just determined as 94. Okay. All right. Now let's times both sides by sine 33. The sine 33 on both sides. All right. And then these two cancel out. And then let's plug this into our calculator and see what we get. C. So we have, clear that, 617 sine 33 divided by sine 94. All right, answer is 336.86. Let's see how many decimal places. Well, we gotta round it to the nearest whole number. So let's see. If we round it up, it's gonna be 337 meters. Okay, so A, the distance between Warsaw and Koldru is approximately 337 meters. All right, so our correct answer for this is option letter C. All right, let's take a look at question 16. So it says, given triangle ABC with A equals 11, B equals 12, and big A equals 39 degrees, find little c, round your answer to 2 decimal places. So what we're going to do here is draw a graph of the situation. I mean a shape of the situation. So there goes my standard triangle ABC. Let's see. This is not drawn to scale. Call this A, B, and C. So that's big B, that's little b, that's big C, that's little c, that's big A, that's little a. So little a is 11, little b is 12, big A is 39. Okay, when we're asked to find little c. All right, so let's see what we have here. We do not have any of the pairs for angle C, so we cannot find it directly. We have to find it indirectly. We have a pair for A and a missing pair for B. So the strategy here will be to find big B first, and then find big C, and then use that to find little c. Okay? So that's the step. All right, so let me just summarize it right here. So we're going to find big B, and then after finding big B, we can use the triangle angle sum theorem to find big C. And after finding big C, we have a pair. And here's the other pair for A to find little c, which is what we are looking for. Okay? All right, so let's do it step by step, starting out with finding big B. All right, so to do that, we're going to go sine big B over little b equals the next pair. We need to have both pairs accounted for, a complete pair, and A satisfies that. So we have sine big A over little a. All right, let's substitute and solve for for big B. So we have sine big B, little b is 12 over 12 equals sine A, sine 39 over little a, which is 11. All right, now we'll multiply both sides by 12 to isolate sine B. So this divides out. and then we have sine B equals. Now, what we're going to do is we're going to plug this into the calculator to see what the value of sine B equals. Okay, so let's go ahead and compute that. Parenthesis 12 sine 39 divided by 11. So it's 0.6865. So sine B is going to be an approximate value, so let's use the right inequality symbol. So sine B is approximately 0.6865. So to get B by itself, we just simply take the inverse sine of both sides. So we have the inverse sine of 0.6865. All right. So let's plug that into our calculators and see what the value of angle B is. So inverse sine, oh, it's not working. So inverse sine of the previous answer, second function negative. Answer is 43.3562. All right, so let's write that down. Big B is approximately 43.3562 degrees. Now we're done with the first step. Now let's put that into our diagram so we know where we're at. So 43.3562. Now we can use the triangle angle sum theorem to find C. Okay. So using that information, we have big C equals 180 minus A plus B. A is 39 and B is 43.3562. All right, so big C is going to be an approximate angular value. Let's see what that is. Plug it into our calculators. 180 minus parenthesis 39 plus. I'm going to insert the previous answer. Close that. Enter. 97.643 6438. Okay, so angle C is approximately 97.6438 degrees. Okay, all right, almost there. Last step. We're gonna now look for find little c because we have one of the pairs for the c's that can help us find the missing pair. Okay, so to find little c, we're gonna go little c over sine big C equals I can use the B pair or the A pair. The A pair is more exact and neat, so I like to use that one instead, okay? A over sine A, this is the formula I'm going to use. All right, so little c over sine big C, we just found sine big C as being 97.6438 equals little a, which is 11, over sine big A is 39. All right, so to get little c by itself, we need to eliminate this denominator, so multiply both sides by sine 97.6438. And then this is 11 sine 97.6438. This divides out. So your final answer, little c, it's going to be an approximate value. So let's go ahead and compute what that is. It's going to be 11 sine, previous answer, I'll insert answer, divided by sine 39. Close that. And our final answer is 17.32. So two decimal places. So it's approximately 17.32. All right. So our answer is option letter D. Option D will be our answer here. Okay. Now let's move on to the next question. Last one for this section. Question 17. In this scenario, it says this is an approximation of the area covered by New Hampshire using a triangle. So it says the state of New Hampshire is approximately triangular in shape. Use the diagram shown at the right to estimate the area to the nearest square mile. So remember the area formula K. If you have SAS situation, you can use the formula K equals 1/2 the first side times the second times the adjacent side sine of the included angle between the two sides. Okay, so let's see if if we can apply this formula directly to this situation. So we have a side, we have an angle, and we have a side, SAS. All right. So guess what? We can apply this formula directly here. We don't even need any formulas to do this. We don't need to label it A, B, or C. So we're gonna go K. Area is 1/2. The first S is 88. The second S is 194. Sine 86. All right. So let's plug this into our calculator and see what we get. So we have 1/2 times 88 times 194 sine 86. All right. So we'll plug all that in. Answer is going to be 85.2067 square miles, but we're rounding it to the nearest integer. So our area, approximate area for New Hampshire is 85.8515 square miles, and that is to the nearest integer, and that is option letter D. All right. Good day, students. Welcome to part 4 of the midterm review. In this section, we're going to be focusing on operations on complex numbers, quotient, product, and towers of complex numbers in polar form, including the use of the Marvelous Theorem. Let's go ahead and take a look at question number 18. It says, what is 6 cosine 20 plus I sine 20 to the third power in polar form? So to do this, we're going to be applying the Marvelous Theorem. Let's write down what the theorem is first, and we're going to apply it. So we have a complex number, r cosine theta plus I sine theta raised to the nth power. That is going to become the radius raised to the nth power times cosine of the power times the angle plus I sine the power times the angle. Okay? So you basically raise the radius to the power and multiply the power by the angles. That's what that's basically how you apply the Marvelous theorem to finding the powers of complex numbers in polar form. All right, so let's apply this formula to this situation. We have r is, you can clearly see that r is 6 and n is 3, and the angle theta is 20 degrees. Okay, so let's apply it here. So we have 6 cosine theta plus I sine, oh wait, let's fix that. 6 cosine, I'm going to make a substitution. 6 cosine 20, because that's the value of theta. 6 cosine 20 degrees plus I sine 20 degrees. We're raising that to the third power. Okay? So that's going to be 6 to the third, because we have the radius to the power. So 6 to the n, 6 to the third times um, cosine, cosine 3 times 20 plus I sine 3 times 20. Alright, so that's how you have it. So it's going to become 6 to the third is 36 times 6 is 216 uh, times cosine 3 times 20 at 60 degrees plus I sine 60 degrees. Alright, so that goes the answer. So our answer for question number 18 is D. Alright, let's move on to the next question. 19 says, which of the following is a trigonometric form of the complex number the square root of 3 plus I? Alright, so we're going to change this to trigonometric or polar form, this complex number in a plus bi form. In order to do that, let's write down what the polar form of a complex number is. A trigonometric form is basically r cosine theta plus I sine theta. Okay, so we need to find r and theta. Okay, if I can find r and theta, Then I'll just substitute the values into this formula, and that will be the trigonometric or polar form of this complex number. Okay. All right. So we're gonna apply two formulas that are included in your formula sheet. Let's pull that up real quick. So we're looking for r and theta. So if you look on the bottom of your formula sheet, you see the formulas here for r and theta. This is to find r and theta, and then this is to find x and y. So we're going to be using the first set of formulas, okay? All right, so now to find r, we're going to be using the Pythagorean theorem. So first of all, we need to find x and y because r is, from the formula, is basically the square root of x squared plus y squared, okay? All right, so in this case, we have the complex number root 3 plus the coefficient of I is 1, right? Plus 1i. So this is x and this is y. Okay, so x equals root 3 and y equals 1. So that's what I'm going to plug into this formula. So we're going to have the radius equals the square root of root 3 squared for the x plus 1 squared for the y. Alright, that equals square root of root 3 squared is 3 plus 1 squared is 1 equals root 4. The answer is 2. So r is 2. Okay, now we need to find theta. Going back to the formula, you find out that theta is equal to the inverse tan of y over x. Okay, and if x is let's go back to the formula. Let me show you a very quick detail. Um, if x is negative, we have to add pi. If x is positive, we just leave it alone. Okay, in this case, we see that x is greater than 0, so we do not have to x is greater than 0, so we do not have to add anything to this formula. Okay, all right, so let's make use of the formula. So theta is going to be the inverse tan of y over x, which is 1 over root 3. um, let's let's convert this into a form that's consistent with what we have on our unit circle. So 1 over root 3 can be simplified. You multiply by root 3 and root 3 on the top. And then we have root 3 over 3. Okay? So this is the same thing as taking the inverse tangent of root 3 over 3. Alright, so let's go back to our table of common trig angles and find out what the inverse tan of root 3 over 3 is. So let's see. Uh, there you go. Alright, so we have root 3 over 3. Where are you? For tan, root 3 over 3 basically takes you up to 30 degrees. Okay, so the tan of root 3 over 3 right here takes you straight up to 30 degrees. So that's what inverse tan of 30 is. So let's go ahead and do that. So it's going to be, theta is going to be 30 degrees. All right. Now that we have theta and r, we're going to put them together into the formula. So it's going to be r is 2 times cosine theta, which is 30 degrees, plus I sine 30 degrees. And there goes your final answer. This is the polar form of root 3 plus I. Okay? So the answer is option letter B. Alright, let's move along to the next question, number 20. Alright, so for 20, we want to convert this complex number in polar form into a rectangular form. So we have 14 times cosine 4 pi over 3 plus I sine 4 pi over 3. Okay, so we just simply use our chart to evaluate these trig values, and then we'll distribute 14 into both of them. Okay, so let's just bring down the 14. We have 14 times cosine 4 pi over 3. Let's see, cosine 4 pi over 3. Um, we're gonna call up our unit circle. Actually, we can just use our table of trig ratios to do that. So cosine and sine of 4 pi over 3. If you look here, Cosine 4 pi over 3 is right, is negative 1 half. And sine 4 pi over 3 is negative root 3 over 2. Okay, so negative 1 half and negative root 3 over 2. The sine and cosine values of 4 pi over 3, which is also equal to 240 degrees. All right, so let's go ahead and put that in. From our chart, cosine 4 pi over 3 is negative 1 half plus uh, sine 4 pi over 3 is negative root 3 over 2, so negative root 3 over 2i. Let's simplify that a little bit. So we have 14 times negative 1 half minus root 3 over 2i. Now, to finish this off, we just simply distribute 14 into both of these. So we're going to have, it's going to equal negative 14 over 2 minus 14 root 3 over 2i. This I can divide by 2 top and bottom. So that will give me negative 7. And then this one divided by 2 top and bottom, you have negative 7 root 3i. And there goes your final answer of 14 cosine 4 pi over 3 plus I sine 4 pi over 3 in rectangular form. So our answer is option letter B. Alright, let's move on to question number 21. We have to find 1 minus I root 3 raised to the 12. We can use the Marvelous Theorem here, but let me just show you a trick using a calculator to do this. To do this with a calculator, we can just go parentheses 1 minus, where's I? Where are you? I root 3 raised to the 12th power. Yeah, and you can see that it's 40, 4096. Okay. All right, so our answer is going to be option letter A. So this is equal to 4096. All right, let's move on to the next question, question 22. We're going to be applying the quotient property for complex numbers. So when you're dividing two complex numbers, z1 and z2, the quotient is basically r1 over r2 times cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Okay? So basically, you find the quotient of the radii, and then you multiply it by cosine of the difference of the angles, and I sine the difference of the angles. All right, so we can see in this problem R1 is 21, R2 is 3. I don't know where that came from. R2 is 3, theta 1 is 55, and theta 2 is 65. All right, so let's compute z1 over z2 using the formula indicated above. So r1 over r2 is going to be 21 over 3, okay, times cosine theta 1 is 55 minus theta 2, 65, plus I sine theta 1, 55, minus theta 2, 65. Okay, so it's going to be 21 over 3 is 7. 7 times cosine negative 10 plus I sine negative 10. And there goes your final answer. So our answer is option letter D. All right. Okay, so it says, question 24 says, find the value of A so that vectors U, which is AI minus 9J, and vector V, which is 4i plus 4J, are perpendicular. So to do this, the two vectors are perpendicular. That means U dot V has to be 0. Okay, so what we're going to be doing is we're going to be solving an equation, which is U dotted with V equals 0. Okay, so let's go ahead and do that. So U dot V is AI minus 9J dotted with 4i, sorry, I said J, 4i plus 4j, 4i plus 4j equals 0. Okay, so to find the dot product in this ij form, you just multiply the i's and the j's and find the sum of the products. Okay, so it's going to be a times 4 That's the i's, and then the j's plus 9 times, actually negative 9 times 4 equals 0. Alright, so you have 4a minus 36 equals 0. Alright, to get a by itself, you add 36 and divide by 4. Alright, let's go ahead and do that. Add 36, you have 4a equals 36. And then divide both sides by 4. And then your final answer, a, equals 9. Alright, so when a is 9, vector u is going to be perpendicular to vector v because your dot product will be 0. Okay, so there you have it. Alright, let's move on to the last question. It says true or false if tan x is root 3, then tan 2x is negative root 3 over 2. So I'm going to show you how to do this using a calculator. So first of all, let's see what this value is. What's tan 2x? Tan 2x is equal to negative root 3. What is the approximate value of negative root 3? Let's plug that into our calculators and see what we get. Figure that out. Negative root 3 is negative 7321. Negative 7321. Okay, so it's approximately negative 1.7321. Alright, now let's use this to find tan 2x. So we know that tan x is root 3. If tan x is root 3, then what is x going to be? You take the inverse tan of both sides, right? So you take the inverse tan of tan x equals the inverse tan of root 3. Let's divide out. So you get x equals the inverse tan of root 3. Now we're looking for tan 2x, right? So what is 2x? If x is inverse tan over 3 and 2x, you multiply both sides by 2. 2x equals 2 times the inverse tan over 3. So we want to find tan of 2x. This is 2x, so the tan of 2x is tan of 2 times the inverse tan of root 3. Okay, alright, let's plug this into our calculator and see what this is approximately equal to. If this is equal to that, then our statement is true. If it's not, then the statement is false. Alright, so let's go ahead and do that. Tan of 2 times the inverse tan over 3, negative 1.7321. Is approximately negative 1.7321. So we have a match. They're both equal. So guess what? The statement is true. Alright? So that's that.